everyone. Welcome to ISF College of Pharmacy, Moga, Punjab, India. Myself, Dr.Sankha, alongside with my co-team member, Dr. Rai sir and Dr. Singh sir. Today, we will be learning about nano-emulsion. As you know, pharmaceutically, nano-emulsion are booming right now. Nano-emulsions are basically biphasic dosage form. In this preparation, we use cholesterol, soy lecithin, chloroform, oleic acid and water. We have utilized two different methods, but optimization was done by high pressure homogenization technique. Basically, there are two different processes. One is low shearing technique, another is high shearing technique. We have utilized high shearing techniques over here. Preparation of nano-emulsion, we utilize ultra-thorax high shear homogenizer with a capacity of 25,000 rpm. While optimization, we found out that 12,500 rpm is the best rpm for this preparing stable nano emulsion. Next step is probe sonication. After preparing nano emulsion utilizing high speed homogenization, now it is very important to go for nanonization of our nano emulsion. For that purpose, we need probe sonicator. Friends, in our laboratory, we are having probe sonicator with a capacity of 20 kHz. For the optimization purpose, we need probe sonicator. What is the need for probe sonicator is it will provide equal distribution of particle size and more stable nano emulsion. In our optimization process, we use 20 kHz frequency for 15 minutes while pursuing probe sonication. After probe sonication, we will be going for a characterization using particle size and zeta potential analyzer. As you know, we already prepared nanonized nano-emulsion by utilizing high-speed homogenizer and probe sonicator method. Next step is to filter utilizing 0.22 micrometer membrane filter. The importance of membrane filter is it produces desired particle size. Friends, we will be measuring zeta potential and particle size of our nano formulation utilizing Delsa Nano C particle size and zeta potential analyzer manufactured by Beckman Coulter, USA. The basic principle of Delsa Nano C is a photon correlation spectroscopy, which determines particle size by measuring the rate of fluctuation in laser light intensity scattered by particles as they diffuse through a fluid. The range of particle size we can measure with this instrument is 0.6 nanometer to 7 micrometer. The zeta potential, which we can measure from minus 100 millivolt to plus 100 millivolt. The correlation range is from 0.001% to 40%. And the temperature range for this instrument is for 10 degrees centigrade to 90 degree centigrade. Friends, this is the socket specifically designed for Zeta potential measurement. The capacity of this is almost around 0.7 ml. The most important part of this is once we are going to pour the liquid or water or nano emulsion over here, it has to maintain a proper balance or level from the left hand side to right hand side. Make sure there should not be any kind of bubbling preparation during this process. If any bubble creates, then you may not get proper Zeta potential. Friends, we are going to measure the particle size by utilizing Delsa Nano C, and this is the specific socket for measuring the particle size. Let's see how we are going to place the socket inside. Just open it. This is very delicate, so we have to keep very smoothly. Make sure everything has been placed properly. Now close the door. Friends, we are going to measure particle size using Delsa C Nano sizer, but before that we need to install Delsa Nano 2.21 software in our respected desktop or as well as in laptop. Let's open the software and see the proceedings of this software. Give some time to system to get validated itself. This is the overall layout of Delsa Nano Coulter software. As you can see, this is the start button, this is a stop button, this is addition to measure SOP. Now we already prepared our desired SOP and we already post in it. For the particle size measurement, there is a specific SOP. For the measurement of Zeta potential, there is a different SOP. Here in the data acquisition, once we click, we can see all the layout. Here in this place, you can see the intensity monitor, where you can check the intensity also for our given sample. Here this picture indicating the software itself detected that this is the particular slot which actually we have placed. The refractive index, viscosity and other are indicating the liquid status of the given solution. Next is our size analysis. Here we can see n number of size analysis of previous work which actually automatically record in it. So once we are going to start, we will show you the process, but right now I want to show you how we can open the previously performed experimental data. We are going to open any old formulation or any other documents which previously performed. Here we click it and go for open file. As you can see, you get a proper layout of the previously performed particle size measurement. This is a perfect peak of histogram and the intensity was being measured. Next we will be learning each and every tool tab while we perform our experiment.
Start.
Next we will be checking our zeta potential measurement. As you can see, same procedure will be followed. Select any file and open the file. Once you open it, you will find the zeta potential measurement and other details of the relevant experiment. We will be also learning the toolbar of this experiment while we pursuing our work. We are going to start our experiment. Here you can see our start button, and we already selected a general common SOP, standard operating procedure for measuring particle size. Let's begin. We need to fill our data. We can, for the experiment purpose, we can keep any name over here. Let's give A, B and C. But once you are going to start your experiment, you should keep your name properly. That's okay. Now the experiment have just begun. As you can see over here, the particles are showing nanoparticles almost around 220.3 and polydispersibility index 0.252. It is a continuous process. It will be take little more time, and total time there are different cycles available for it. We already placed 70 cycle. Right now we are on 15 cycle. It will go up to 70 cycle, and we will get a cumulative result of this formulation. As you can see, we already performed our experiment for 70 cycle. Now we can see that the diameter is 223.8 nanometer. Polydispersibility index is 0.218. And we can observe a very good histogramic plot of our prepared nano emulsion. Our nano emulsion comes around 223.8 nanometer, which indicates it is a very good nano emulsion, as well as the polydispersibility index shows a very good and stable nano emulsion property. Now we will see the different layout of this instrument toolbar of the. We know that we have taken 70 acquisition. The cumulative 70 acquisition report was been generated by the software. As you over here you can see the diameter, mean diameter, intensity in centimeters unit, and all the details can observe in this respected toolbar. See that 70 cycle. All the mean diameter was been measured, and cumulatively you get here 223.8 nanometer. If you can go to volume distribution, you can see how the cumulative volume was distributed. That indicating the total distribution level of the particles within the nano emulsion. So in that also we can see the distribution of numbered of particles, and finally we can see a logarithmic graph with the time and log intensity. For any researcher, it is very important to collect the data from the software. For that reason, what you need to do is go to the file, go for print preview, select preview item, then go OK. You can see a PDF file was being generated with all the relevant information. Now you can directly take printout or take a PDF format, and further you can process for your publication. Already fill our sample through this syringe, 5 ml syringe, in the inside of these tubes, and this tube and this apparatus, this already fill our sample inside of the tubes of this Zeta potential measurement socket. And as I already told, there should not be any kind of air bubble inside. So before placing this socket, we already make sure that there should not be any air bubble. Now we are going to place our socket inside of our Delsa Nano C apparatus instrument. As I already told, it is too delicate, so we have to place it very smoothly. After you get one click sound, that means the socket has been placed properly. Now close the window. When we start our Zeta potential measurement, once again we need to restart our Delsa Nano Batman Coulter software. So once we start, the software automatically read and it will show the SOP for measuring the Zeta potential. Now let's start Zeta potential measurement. You can see over here it is showing Zeta flow and Zeta high concentration cell. We can click over here and we can start our procedure. And once again we are going to keep any name, but when you perform the experiment you have to give your own name. Friends, as you can see, when we change the slot, you can identify the flow cell diagram has been changed, which indicates that now we are ready for Zeta potential measurement. For that reason, we have to follow the standard operating procedure which is already installed, Zeta flow cell. We have to click it over here and just we need to press the start button. Once we started, we are going to give a different name. And press OK. Now you can listen certain sound from the software end. It's indicating the software, the instrument is started maintaining its accommodation mode. Now the process has just begun. Look at the fluctuation over here. Once again, the instrument will be taken cumulatively so many results for Zeta potential measurement. selection of our excipients like cholesterol, soy lecithin, oleic acid formulation is comprising with cholesterol. So we can see our zeta potential is in negative, minus 1.30. We also observe the electric field is up to around 16.32 and refractive index 1.33 to 8, and the viscosity of the solvent or the sample was 0.8898 centipairs. From these outcomes, we also observe that there are many toolbars available. Based on our requirement, we can customize our procedure. Now we will be directly go to how to take a printout of our research or in zeta potential. So we'll go to the file and go for a print preview, and we'll select all the things, distribution graph. We can go for distribution graph and press OK, and we can find the entire detail of zeta potential studies. So as you know, the zeta potential and particle size analysis is prerequisite and very indispensable parameter once of characterization of any nano formulation. If you want to publish in a very reputed journal, you need to keep these two characterization parameters. So here we end our demonstration of preparation of nano emulsion and subsequent characterization parameter. We hope, I'm confident enough that you have learned today about high-speed homogenization and ultrasonication and profsonication, subsequently the zeta potential and particle size analyzer from Beckman Coulter Delsa Nano C apparatus. I hope you have understood the basic principle of zeta potential and particle size measurement by our sample nano formulation, nano emulsion. And I wish you all the best for your future and endeavor. Thank you so much.